Is the universe truly infinite, stretching out endlessly, filled with galaxies? Or does it have an edge, a boundary we can never cross? For millennia, we've looked up at the night sky and wondered about our place in the grand scheme of things. This question challenges the very limits of our understanding. It also profoundly affects our perception of our place in the cosmos. Mathematician Marcus du Sautoy sees science as a grand adventure, a constant striving to explore the uncharted territories of knowledge. It's about mapping what lies just beyond our grasp, constantly expanding the boundaries of our understanding. Our journey began with the naked eye, transforming initial awe into structured inquiry. We moved from telling stories about the stars to developing a rigorous scientific method for understanding them. We used telescopes, ever refining our instruments to see further and more clearly. Mathematics and the boundless capacity of the human mind to reason and imagine. The quest to answer whether the universe is infinite or finite is a story of ever-evolving tools and brilliant ideas, and of the unwavering courage to ask the biggest questions. And so, with that spirit of inquiry, we begin our journey to grapple with the question of infinity itself. Since the dawn of consciousness, humanity has gazed up at the night sky, filled with wonder and a deep desire to understand our place in the universe. Ancient observers, lacking our modern tools, imagined the night sky as a grand rotating dome, a vast and encompassing structure. This dome, which they called the celestial sphere, was believed to have Earth at its very center, a concept that shaped our understanding for centuries. This mental model, though ultimately proven incorrect, allowed us to chart the positions of stars and predict their movements across the sky with surprising accuracy. By organizing the stars into constellations and tracking their paths, they were turning chaos into order, creating a sense of predictability in the heavens. The Greeks, with their profound love for geometry, were particularly fascinated by perfect shapes like the Platonic solids, believing they held the key to understanding the universe. They sought mathematical harmony in the heavens, attempting to find geometric relationships that could explain the movements of celestial bodies. Later thinkers like Kepler, building upon this foundation, tried to use these perfect geometric forms to explain the seemingly complex and irregular planetary orbits, searching for underlying patterns. They were searching for a divine blueprint, a hidden order that governed the cosmos and revealed the mind of the Creator. The celestial sphere, though ultimately proven to be an inaccurate representation of reality, was nonetheless a remarkably useful framework for mapping the sky. It provided a basis for developing celestial coordinate systems that are still used by astronomers and navigators today, a testament to its enduring utility. It marked our first significant leap from a world of mythology and folklore to a more systematic, geometric, and ultimately scientific understanding of the universe. This tidy, finite universe, with Earth at its center, gave us a comforting and reassuring place in the cosmos, a sense of belonging. The celestial sphere acted as the ultimate boundary, the edge of everything that existed, providing a sense of closure and completeness. But as our tools and techniques for observation sharpened, revealing ever more detail, this elegant and comforting model, so deeply ingrained in our understanding, would inevitably be shattered by a wave of new discoveries. The cosmos was about to become vastly larger, and far stranger and more complex than anyone had previously imagined, challenging our very notions of reality. Our journey of discovery was only just beginning, and the universe held secrets beyond our wildest dreams. To move beyond the celestial sphere, we needed to measure cosmic distances. The breakthrough was trigonometry, the study of triangles, which let us calculate unreachable distances using angles and sides. Ancient astronomers like Aristarchus used this method to estimate the distance to the sun, realizing it was vastly farther than the moon. This shattered the idea of a small, tidy universe. Trigonometry became our cosmic measuring tape, revealing the true scale of our solar system. Today we use parallax, measuring a star's apparent shift as Earth orbits the sun, to calculate stellar distances. Even the nearest stars are trillions of kilometers away, proving the universe is far vaster than we once believed. The old boundaries were gone, the cosmos had opened up. As our measurements grew, so did our imagination. Giordano Bruno, a 16th century philosopher, saw stars as other suns, each with their own planets and possibly life. He envisioned an infinite universe with no center and no edge, challenging the Church's finite human-centered cosmos. Bruno's leap was philosophical, not scientific, but it was revolutionary. An infinite God, he argued, would create an infinite universe. His ideas were deemed heretical, and he was executed for refusing to recant. Yet Bruno's vision was prophetic. Centuries later, telescopes revealed a cosmos filled with billions of galaxies and stars, echoing his dream. The universe was no longer a small, ordered bubble. It was a vast, possibly infinite expanse. Bruno became a martyr for the idea of infinite worlds, his legacy, daring to imagine beyond the limits of his time. A key discovery wasn't about size but about light itself. In the 17th century, astronomers realized light travels at a finite speed, about 300,000 kilometers per second. This means we never see the universe as it is now, only as it was. Sunlight takes 8 minutes to reach us. The nearest star's light, 4 years. When we look at distant galaxies, we're seeing millions of years into the past. Telescopes are time machines, letting us witness the universe's history unfold. The farther we look, the further back in time we see. We can only observe the universe's past, never its present. This cosmic time delay is both a limit and a gift, revealing the story of everything. Our senses provide a specific window into reality, but it's a window with definite boundaries. We perceive the world through touch, taste, smell, sight and sound, each constrained by its own physical limitations. We see only a sliver of the electromagnetic spectrum. Beyond this visible range lies a universe of unseen radiation. To explore the cosmos, we built new tools to capture signals beyond our direct perception. We constructed radio telescopes to detect faint radio waves from distant galaxies. We developed X-ray and infrared telescopes to reveal the hidden heartbeats of stars. Each telescope, sensitive to a different part of the electromagnetic spectrum, reveals hidden aspects of the universe. Mathematics became our second sense, a powerful tool for understanding the universe. It provided the language to describe what we could never see directly. Concepts like curved spacetime and the bizarre world of quantum mechanics exist only in equations, yet they are essential for understanding the universe. Technology and mathematics together let us probe deeper, detecting neutrinos, launching space telescopes and building complex computer models of the cosmos. Every discovery reveals new mysteries. The universe's expansion is accelerating, driven by dark energy. Galaxies are held together by dark matter. These unknowns make up 95% of the universe. Our tools show us only a tiny fraction of reality. The more we learn, the more we realize how much remains unknown. So is the universe infinite? The truth is, we still don't know. Current data suggests the universe is flat and likely infinite, but we can only observe a finite bubble, the observable universe. Beyond that, we have no way of knowing what lies. Perhaps the universe curves back on itself, or perhaps it stretches on forever. We are explorers on a vast sea, unsure if there's an edge or a distant horizon we can't yet see. Science may never answer every question, but the quest itself is endless. Each answer leads to deeper mysteries. Our curiosity ensures there will always be new horizons to explore. The journey continues as long as we dare to ask, what's out there?